Basic principles of a car. Understanding how cars convert energy into motion. A car is essentially a complex machine designed to convert fuel into motion. At its core are several key systems working together seamlessly. The basic principle of a car involves a chain of energy conversion. It starts with fuel, which is burned in the engine to create energy. This energy is then transferred through the transmission to the wheels, ultimately creating motion. A car requires multiple systems working together seamlessly. The engine converts fuel into mechanical energy. The transmission controls power delivery to the wheels. The steering system controls direction, while the braking system allows the vehicle to slow down or stop. The electrical system powers electronics and the vehicle's starting system. Modern cars typically use one of two main power sources. Internal combustion engines burn gasoline or diesel fuel using pistons and cylinders and are found in most conventional vehicles. Electric motors, powered by batteries, provide an alternative with zero direct emissions and are becoming increasingly common. In summary, a car is a complex machine that converts energy to motion through multiple interconnected systems working in harmony. The engine is the heart of a car, transforming fuel into the mechanical energy that powers movement. An internal combustion engine consists of several key components working together. These include cylinders where combustion occurs, pistons that move up and down, connecting rods, and the crankshaft that converts linear motion to rotation. Most modern cars use a four-stroke cycle: intake, compression, combustion, and exhaust. Let's focus on one cylinder to understand how the four-stroke cycle works. The four strokes are intake, compression, combustion, and exhaust. During the intake stroke, the piston moves down, drawing a mixture of fuel and air into the cylinder through the open intake valve. In the compression stroke, both valves close and the piston moves upward, compressing the fuel-air mixture into a small volume. The combustion stroke begins when the spark plug ignites the compressed mixture, creating an explosion that forces the piston downward. Finally, during the exhaust stroke, the exhaust valve opens and the piston moves upward again, pushing out the burnt gases. There are two main types of internal combustion engines: gasoline and diesel. Gasoline engines use spark plugs to ignite the fuel-air mixture, while diesel engines rely on high compression to create enough heat for spontaneous ignition. Diesel engines have higher compression ratios, typically between 14:1 and 25:1, compared to gasoline engines with 8:1 to 12:1 ratios. This gives diesel engines more torque at lower RPMs, while gasoline engines can achieve higher revolutions per minute. Engine power is measured in different ways around the world. In the United States and United Kingdom, horsepower is the common unit, while kilowatts are preferred in Europe and many other parts of the world. 1 horsepower is approximately equivalent to 0.745 kilowatts. The engine's power rating determines how quickly a car can accelerate, its top speed, and its ability to handle loads like towing or climbing hills. The steering system is what allows the driver to control the direction of the vehicle. Most modern cars use rack and pinion steering. This system converts the rotational motion of the steering wheel into the linear motion needed to turn the wheels. When the driver turns the steering wheel, the pinion gear rotates, moving the rack side to side. This motion is transferred to the wheels through tie rods. Many vehicles are equipped with power steering, which reduces the effort needed to turn the steering wheel. Hydraulic power steering uses fluid pressure from a pump to assist steering. Let's now examine the suspension system, which connects the car to its wheels while allowing relative motion between them. The suspension system consists of springs, shock absorbers, and various linkages. Springs support the vehicle weight and absorb impacts, while shock absorbers dampen spring oscillations. When a car hits a bump, the suspension compresses to absorb the impact, then extends back to maintain tire contact with the road. The suspension system performs several critical functions for vehicle operation and passenger comfort. Advanced vehicles may feature adaptive suspension systems that automatically adjust based on driving conditions. These systems use electronic controllers to change damping rates in real time. In comfort mode, the suspension is softer for a smoother ride. In sport mode, it becomes firmer for better handling and reduced body roll during cornering. The combination of steering and suspension systems is fundamental to a vehicle's handling characteristics, determining how it responds to driver inputs and road conditions. The braking system is one of the most critical safety systems in a vehicle. Most modern vehicles use a hydraulic brake system that converts the force from your foot into hydraulic pressure. This pressure travels through brake lines to the wheels, where it activates the brake mechanisms. When you press the brake pedal, hydraulic pressure is generated in the master cylinder and transmitted through the brake lines to the wheel brakes. Let's take a closer look at a disc brake system, which is the most common type in modern vehicles. A disc brake consists of a brake rotor attached to the wheel hub, which rotates with the wheel. The brake caliper is mounted over the rotor and contains hydraulic pistons and brake pads. When brake pressure is applied, the hydraulic piston pushes the brake pads against the rotor. This creates friction between the pads and rotor, which converts the vehicle's kinetic energy into heat, slowing the wheel. Modern vehicles are equipped with anti-lock braking systems, or ABS, which prevent the wheels from locking up during hard braking. The ABS uses wheel speed sensors to monitor the rotation speed of each wheel. This data is sent to an ABS controller, which analyzes wheel rotation speeds many times per second. Let's compare braking with and without ABS. During hard braking without ABS, wheels can lock up, causing the vehicle to skid and lose steering control. With ABS, the system rapidly pulses the brakes, preventing wheel lockup. This allows the driver to maintain steering control during emergency braking. Many modern braking systems include electronic stability control, or ESC, which works alongside ABS to help maintain directional control. ESC detects when the vehicle's direction differs from where the driver is steering, indicating a skid or loss of control. ESC automatically applies the brakes to individual wheels and may reduce engine power to help correct the skid. This helps maintain the vehicle's stability and keeps it on the driver's intended path, significantly reducing the risk of accidents. Engines generate significant heat during operation and require specialized cooling systems to prevent overheating. When an engine operates, it can reach temperatures of over 200 degrees Fahrenheit, creating enough heat to damage components if not properly managed. Most cars use liquid cooling systems with 4 key components: a radiator, water pump, thermostat, and coolant that circulates through the engine. The coolant, typically a mixture of water and antifreeze, absorbs heat from the engine as it circulates. The water pump drives this circulation, while the thermostat regulates the flow based on engine temperature. The lubrication system reduces friction between moving parts in the engine. Oil is stored in the oil pan at the bottom of the engine. The oil pump draws oil from the pan and forces it through the oil filter to remove contaminants. The clean oil is then distributed to critical engine components like the camshaft, bearings, and cylinder walls. Both cooling and lubrication systems are essential for engine longevity and efficiency. A well-maintained engine can last hundreds of thousands of miles, while neglected systems can lead to catastrophic failure. Modern vehicles have warning indicators that alert drivers to potential cooling or lubrication problems. A temperature warning light indicates an overheating engine, while an oil pressure light signals lubrication issues. Regular maintenance is crucial. Check coolant levels, change oil and filters at recommended intervals, and promptly address any leaks to prevent serious engine damage. After combustion, exhaust gases must be safely removed from the engine and treated to reduce harmful emissions. The exhaust system includes several key components that work together to manage these gases. The exhaust manifold collects gases from each cylinder and directs them into a single pipe. Next, gases flow into the catalytic converter, which transforms harmful compounds into less harmful substances. The muffler reduces the sound of the exhaust gases, making the vehicle quieter. Finally, the tailpipe expels the treated gases out of the vehicle. Let's look more closely at the catalytic converter, a critical component for reducing emissions. The catalytic converter contains precious metals like platinum, palladium, and rhodium that act as catalysts. These catalysts facilitate chemical reactions that convert harmful pollutants into less harmful compounds. Modern cars include additional emissions control systems to further reduce environmental impact. The exhaust gas recirculation system, or EGR, reduces nitrogen oxide emissions by recirculating a portion of exhaust gases back into the engine. Evaporative emissions control systems capture fuel vapors that would otherwise escape into the atmosphere. These systems help vehicles meet increasingly stringent environmental regulations worldwide. Modern vehicles incorporate numerous advanced technologies that enhance safety, efficiency, and convenience. Let's look at 5 key technologies that define modern vehicles. Regenerative braking systems recover energy during deceleration that would otherwise be lost as heat. This technology converts kinetic energy back into electrical energy to recharge the vehicle's battery. Start-stop systems automatically shut off the engine when a vehicle comes to a stop, such as at traffic lights or in heavy traffic. The engine restarts instantly when the driver releases the brake, reducing fuel consumption and emissions. Advanced driver assistance systems, or ADAS, include technologies like adaptive cruise control that maintains a safe distance from vehicles ahead, lane keeping assistance that prevents unintentional lane departures, and collision warning systems that alert drivers to potential hazards. Modern vehicles offer extensive connectivity features that integrate with smartphones and the internet. These include infotainment systems with touchscreens, wireless phone integration, GPS navigation, and over-the-air software updates that keep the vehicle's systems current. Hybrid and electric vehicles represent the cutting edge of automotive technology. Hybrids use both internal combustion engines and electric motors to optimize efficiency, while fully electric vehicles eliminate fossil fuels entirely, relying solely on battery power and electric motors. These advanced technologies are revolutionizing the automotive industry, making vehicles safer, more efficient, and more connected than ever before. As technology continues to evolve, we can expect even more innovations in the coming years.